So Friendyno, this is a small power generator with a rotor linear motion. We have a project called environmentally friendly small power generator with a rotor linear motion, which implemented by Ventspils University of Applied Sciences and Latvia joint stock company. And here you see list of participants. So we have researchers, engineers, commercialization experts, again engineers. Team leader is Vladislavs Bezrukovs, and idea of this project is it's quite long history, but in last years, new forms of vernier hybrid permanent magnet machines, which are based on the principle of variable reluctance, have come in sight. Along with simple design, these machines offer a compact direct drive solution for low speed and low power applications. We use similar principle of variable reluctance in proposed permanent magnet machine with magnet flux switching. So project devoted to make a new type of electromagnetic machine. The magnetic flux switching principle was used for the development of new bicycle generator design. And this generator, it can be used in different areas, but we focus it for bicycle well electronics. Additionally, here is used unicore technology for vast free production of a generator of magnetic circuits. So we apply new type of technology to produce magnetic circuits and magnetic cores, which allow us to make it more simple and cheaper. And here you see some images or figures of how this system can work. So we have magnetic cores, we have moving part of rotor, which is linear or circular, and permanent magnet inside. During this project, we have developed several prototypes and several designs. You see here 4 different types of these machines that was investigated. And historically, in 2009, was produced first idea and first homemade prototype, which got a prize, and these foster us to make it in a future additional project, and we got some small money for making first research and first experiments. And by these results, in 2009, we was able to formulate and make it finance a RDF project, which is coming to end in next year in February, which focus to develop such type of generator and adjust it to bike, to velo bike. And first of all, of course, we start with design, and we have to find out what is best solutions on how we can put magnets, for example, here, and coils and inductors, magnetic cores, the external magnetic cores with moving part. So any machine have to be have moving part which generate energy output, electrical engineering. By these years, during the project, we have tested several designs. You see, each design is a bit different. All of them have similar parts of the rotating disc and external magnetic core. Some of them also has different type of design with linear motion. So we have stripe which moves linearly, but can generate electric power output as well. So first of all was design. Next one, we have to find out how magnetic flux is moving inside with our generator. So is it working or not? And here it's quite difficult problem, because compared to original electrical machines, which is symmetrical, our prototypes, our designs are not symmetrical, and we have very complicated 3D magnetic flux movement here. You see here magnetic flux in a slice or in a 3D, so 3D space. To achieve these measurements, we use complicated software, so SolidWorks for 3D modeling, and addition to SolidWorks, electromagnetic EMV solution add-on, which allow us to calculate 3D magnetic fields. And here is quite difficult to find out so parameters of this generator from one side and pieces of electrical flux as well. So we found out and model different kind of switches. Here you see one type of switch what we use in last versions, and magnetic cores which we develop here. So each type of model have to be calculated for magnetic field, and each calculation is quite difficult, so it takes a couple hours for model. And during last year we have, and I can say around 1,000 calculations for different parameters of this generator, so it's very time-consuming work. But afterward, we have designed 3D model. We have calculated magnetic field. Next step, it is to check if our assumptions are working or not. And together with Latvia was created a prototype, several prototypes of this generator, and we derive characteristics of this generator. And fortunately, our mathematical modeling and assumptions, what we did just purely mathematically in modeling, and physical experiments are quite close one to another. So in total, we have around 10-15% of correlation between modeling and physical experiment results. And here you see some examples of power outputs from our generator. So, and frequency plot. So finally, we found out that this generator is working. It's producing power, and we know how to model its parameters and how can adjust auto parameters in virtual world using SolidWorks. So these ideas and this generator different types and different designs was patented, and here you see the list of patents which was started in 2008 and most current 2020 was implemented by project. Additionally, we found out that this idea can be commercialized. So it's not just research, it's research focused to make some product. And we make it, register it our trademark, Friendyno, Friendly Dynamo. And here you see how it looks. So it's a Ventspils University College, Applied University of Sciences trademark. Currently, we have developed generator, but not only generator is needed as a product. So we need electronic parts, and my colleagues in next presentation will show electronic components designed to work together with generator, and main goal to make a system which allows to everyone who ride bike power its smartphone or electronics like a navigation system, and make it easy and more like pleasant drive. So finally, we assume so our generator and system together is cheaper, lighter, easier, and more environmentally friendly to manufacture than concurrent products. Quite technological advance, but can be produced in Latvia. And as you see, we have several designs, and this design can be adjusted to any bike design. So we are quite flexible in this put. And we can adjust our generator to requirements of customer. So was nice picture here, but okay, it's just bike. We also make market segment study and found out what this kind of product can be interested for bike packing and touring bike riders. So leisure riders and enthusiasts from private sector, or rental to leisure riders and enthusiasts from business sector. So people who use bike for long term. So not just half hour or hour or ride, but use it for full day or for several days outdoor somewhere. Possibly, if this product will rise visibility, it will be interested for public bicycle sharing services as well. So I think this is last slide, and then continue close my presentation and waiting for your questions.